Welcome to the final exam, question number 18. And it says that the load capacity of a structural steel column is a function of KL over R. Fair enough. Which of the following statements is correct? Alright, and it has the 1, 2, 3, 4, and then it gives a mixture of both, all of them at the bottom for your answers. So let's say 1, 2, 3, I think it only goes to 4. Yes, it does. Alright, 1, 2, 3, or 4. And remember, we have a column in KL over R. This is radius striation. This is a constant, which you'll find in your steel book. L is the unbraced length. And the R is a function of your section. The K is kind of a function of what your end conditions are. So if you have you could have a fixed, you could have a pinned, you could have a free. That's what your K is. And this is going to be in both directions. For instance, say you have an H-beam. You're going to have the weak and strong axis. That's probably not the best. Let's change color so we can actually see what I'm trying to accomplish here. So if you have your H-pile going this way, your strong axis is going to be right here. So I would even go as far as to say this is your XX axis and your Y axis. And that's assuming that your XX axis is always going to be your strong axis. So that's bending about it. So if you had your hand, I don't know if you've done the right hand rule, but if you had your thumb sticking straight up, your fingers are going in the direction that it would be resisting that moment in. For instance, if you were bending about the XX axis, it would be like that. Which, as you can see, if you're bending like that, then these flanges will be resisting the most, and they'll be the most useful. So, all right, now let's move on to the actual problem here. Let's just go down the list and say yes or no for each. And the first one, it says K is a constant determined by the yield strength of the structural steel. And that's a no. It is determined by the end conditions. So if you have, well, you have a pin to pin, I think that's K equals 1, if I remember correctly. And you could have a fixed, that's horrible drawing, but you know what I mean, a fixed free condition where it's free to translate and rotate. So that has absolutely nothing to do with Fy. Alright, so that's a no. Number 2 says K is a constant determined by the degree of fixity at the ends of the column. And as I said, yes, it's the degree of fixity at the ends of the column. I mean, depending on what your fixity is. Either you can be completely fixed, you can be free to translate, or whatnot. So this is a yes. Alright, number 3. K is a constant that depends on the buckled shape of the column at failure. K is a constant that depends on the buckled shape of the column at failure. And I'm a tentative yes on that. And that's simply because I believe it's a yes, and I'm going to try to explain why. But if I were taking this test, I'd be like, maybe. Let me think about that a little bit more. And essentially what you do is you want to figure out what that shape is. And if you have for instance, what they do when they actually derive all these, you can see that if you did this would match up. This is the exact same as this. So if this is K equals 1, then this would kind of be K equals 2, because as you can say, if I cut this right here, it would have the same shape as if I cut this right here, or if I pretended like this went all the way down. And for instance, when you have I think you understand what I'm saying, and you can derive all of them. For instance, you have fixed. I mean, fixed is going to move like an S if it's free to translate, but not, so it's free to translate that way, it will make an S, and then you can figure out what is this shape and where does it come from that. And this is a little bit more of a difficult derivation than what I've shown you right here. And this is k equals 2, I believe. And you can see that this length is going to be twice that length. And that's where k comes from. Alright, so I know that this is actually a yes. And if you want to look into that further, I would say go look at in a structural book and where they do derive these k's, and you can get that. But I'll do videos on it in the future. But as for right now, I think that's a good enough explanation. All right, number 4. An increase in the value of k results in a decrease in the column load capacity. So it's saying an increase in k. If k goes up, that means KL over R is going to go up. And KL over R, when it goes up, it does result in a decrease. So that's true. Because I always remember this. Sometimes it could be confusing, but you can always remember anything KL over R equals a 100 or above, anything above 100, your moment magnification gets messy. So anything KL over R over 100, you need to start looking at. You don't want a KL over R over 100. You want it under 100 if you can. You can do it over 100, just it makes the analysis a lot more difficult. So that's how my general rule of remembering what that is, and I hope that sticks in your mind if you have a question like this on your test. So that is also correct. So we have an answer. Whoops, that's a yes with 2 S's. We have an S 2, 3, and 4. We have 2 only for A, 3 only. C is 2, 3, and 4. So C is our answer. And as I said, I'll do some more videos on this, how they derive the K factors. And I believe they actually have them listed in the study guide, and they should provide them to you on the test. If not, they're in your Steelbook. And I actually have those tabbed, and I believe you should as well if you own a Steelbook. All right. I will see you on question number 19.